Ladies and gentlemen, good morning. This is Mr. Nambani. I will be assisting Dadele Tina, who's going to be the presenter for this grade 12 memo discussion for physical sciences. I will be doing the admin, so it basically says the recording of this session as well as the registrations thereof. So one key rule will be colleagues, let's give the presenter an opportunity to present, and then immediately after every question then we'll take questions thereof. So with that being said, I will request that we kindly switch off our mics at all times. We also switch off our videos, Mr. Daizani, such that we are in a position of saving the bandwidth and we do not struggle now with connections thereof. Colleagues, with that being said, allow me to say, Ntatele, you can kindly switch on your camera such that you can greet the colleagues, and then we'll get straight into the business of the day. I will keep on admitting the colleagues from my side, and you can now easily proceed with the memo discussion. So with that being said, Ntatele, over to you, sir.
Thank you very much, Dr. Nambane. Colleagues, good morning. You are welcome to participate in this memo discussion for today. I just want to highlight a few things that I really highly appreciate the comments and inputs that you have made towards the success of this memo discussion. It is not an easy task. It's a process that all of us have to go through so that we eventually become better people. That being said, colleagues, I will switch off my camera. I think I've greeted you, and then I will then start with the memo. Colleagues, the issues that have been raised, I've tried to address them. I'm sure there will still be other issues that will arise. I'll see if I will need to consult. I will have to do that. But eventually, we will have to have a final memo and agreement on the memorandum. So what I've done is to try and consolidate those changes that you suggested, and then I've incorporated them into a new document. I've highlighted those changes in red for our memo discussion so that we can be able to see those changes and make those changes. Then the final document, as Latina has indicated, will be issued out after this memo discussions, after everything has been sorted out. Then we will be able to bring a final version. I would also want to indicate, colleagues, that as the Free State, we are number one, and we must try by all means to minimize mistakes and ensure that when we present our papers, especially for national moderation, they are good. And because everybody would be looking at the Free State because it is number one. So we will try to incorporate all the changes that you have come up with, and make sure that whatever challenges are there, we try to address them in the final document. Colleagues, let me start first with uh, this arrangement. Question 6.5. Um, question 6.5. I will scroll to that. And this question, if we look at the English version, I think it was okay, but the problem came with the Africans here, where now we compared methylpentenyl, 2-methylpentenyl with compound B. So it was felt that two variables have been included, and because of the two variables, then the question would not be appropriate. So the decision that we have taken is that we should then take out the 4 marks for question 6.5, so that for both English and Afrikaans, so that we make everything look the same, so that we can have a total of 96 marks. So as we start, we will be looking at the paper from a total of 96 marks. We should also note, colleagues, that the aim really is to ensure that we make use of these papers and whatever experiences we get from the papers to teach our learners and clarify certain things. So it means that when we go back to the learners, we still have to discuss this question, but now we have to make it, we have to correct whatever the challenge was there in the Africa's paper, so that the learners can be able to interact with what was intended out of that question. So I think that is the approach that we will take with all the questions, that the main intention or the main purpose is to ensure that at the end of everything else, then we go back and improve maybe on the understanding of learners, and also how we can deal with the teaching and learning for our learners to understand better. So that being said, colleagues, then we will make the paper, we will mark the paper out of 96 marks. And the second issue that I would like to refer to is on the Afrikaans paper still, question 5.3. 5.3 said learners should write down the structural formula of the compound A. And compound A, if you look at that in the Afrikaans paper, maybe we'll compare it with the English paper. Here the compound is supposed to be hexane, and for that reason, the triple bond in this compound is not indicated. So there was a question around that. But colleagues, if we could look at the memo for that particular question, 5.3, we will note that for 5.3, that is the memo. I think you will agree with me, if I'm not wrong, that if you look at the position of the triple bond of the functional group here, there is no other position where that functional group or the triple bond could be. So I think that works in our favor in the sense that then the triple bond will be between carbon 3 and 4, irrespective of whether the learner has the two methyl groups on the left-hand side or on the right-hand side. So in this case, then I think that covers the question. So as we mark, we will check that the functional group, which is the triple bond, is where it is between carbon 3 and carbon 4. And then the three methyl groups will be there and the whole structure is correct. If the functional group is or the triple bond is not there, then it would definitely mean that that mark will be forfeited, and uh, basically that's it. So it does not affect the nature of the marking. I hope that is clear, colleagues. So that will ensure that we have addressed the issue of question 5.3 in the Africans paper. Then I will go back. Excuse me, colleagues, I could not manage to make a hard copy of the memo or the question paper. So I will have to use this to juggle between the memo and the question paper on the computer. I think we should note that for question 1.1, it says a suitcase is addressed on a table. Which one of the following is the reaction force to the weight of the suitcase as described by Newton's third law? I think there was a mistake there because the answer was pointed out as D, but in actual fact, when we look at Newton's third law, which is a reaction, an action reaction pair in this particular case, the correct answer should be B. So the correct answer should be, why did I change that to make it A? I think I will have to, yeah, I think I made yet another mistake here. It should be B. I wanted to go for B. So please, colleagues, make sure that it is B, not A. This is the corrected memo, but unfortunately, it looks like that question is stubborn. So let's make that B. I will correct that in the final document. Yeah, I think that is the one other issue that we was raised. And now, I think from there, colleagues, we will look at the challenges as we meet them. I will then move to question 2. I think the rest of the questions in the multiple choice are correct. We haven't had anything against those. So correct this, make it B. It seems that was where the problem was. Then I will move to question 2. It says two blocks of masses 4 kilograms and 8 kilograms respectively are connected by a light inextensible string. A second light inextensible string attached to the block to the 4 kilogram block runs over a frictionless pulley. A constant horizontal force F pulls the second string as shown in the diagram. The magnitude of the tension between the two blocks is 120 newtons. Now, learners are asked to ignore the effects of friction, and we have the diagram set out there. And then the first question says, state Newton's second law of motion in words. And what we expect learners to write is that the net force, or when a net force acts on an object, the object will accelerate in the direction of the net force or of the force. The acceleration is directly proportional to the force and is inversely proportional to the mass of the object. So here, the criteria is that if any of the underlying keywords, then when a net force, for example, or phrases in the correct context is omitted, we should remove 1 mark from that, so the learner can get 1 mark. That's more or less like part marking. The second question says, draw a labeled free body diagram showing all the forces acting on the 4 kilogram block. So the forces acting on the 4 kilogram block there are the force acting upwards, which is applied on the 4 kilogram block. And we have come up with the options, and then some additions were made there that we can accept also F applied instead of F. We can accept T, the tension. We can accept FT, or we can accept it if a learner has tension like that. So that is the change that we have brought in there. Then the second force will be the weight of the 4 kilogram block itself. And then the third force will be the tension between, the tension between the 4 kilogram block and the 8 kilogram block. So for the accepted labels there, we have for the weight FG, FW, we have weight, we have mg, gravitational force, or the force that the earth exerts on the 4 kilogram block. I think we can accept all those. And for T, we could, in that place where we put 120 newtons, we could put the tension or T, and then or FT. I think that has to be a subscript, or a learner can write it as FT as it is indicated there, or because here we have FT as a small letter, that can be FT as a capital letter, but in as a subscript. Then we can represent it as a tension, or in Afrikaans as spanning, or F spanning. Now, how do we allocate marks there? We'll award a mark for a label and arrow. So for that mark, we must ensure that for the mark that we apply for this force, there should be a force which is shows the magnitude and the arrow. So we must have the label and the arrow for 1 mark. And then we should not penalize for the length of arrows, since the drawing is not drawn to scale. So we don't really look at the length of the arrows, and we cannot penalize for that. Any additional forces that the learner includes in the diagram will mean that we deduct 1 mark. So in the marking, usually what we will do, if a learner had indicated an extra force there, then we would make a tick for the correct forces, and then because of that additional force, we remove 1 mark from that. So instead of the learner getting the full 3 marks, then we penalize that learner 1 mark for the additional force, and that learner will get a maximum of 2 marks out of 3. The next bullet says, if everything is correct but there are no arrows, then you will also treat it like when there are additional forces, you will you'll mark all these and remove one mark for the having left the arrows. So in essence, the learner can get a maximum of 2 out of 3. Now, another thing is that we should check that the forces uh, make contact with the dot. If they do not make contact, then like in these 2 other bullets, you just deduct 1 mark for that mistake. We do not punish them more than 1 mark. So that is how we would mark that question on free body diagram 2.2. 2.3 says calculate the magnitude of force F applied on the system when it is accelerating. We want to calculate the magnitude of the force F when the system is accelerating. Our memo here, for the sake of time as well, colleagues, will just look at one scenario, like we have upwards as positive and downwards as positive, but we'll look at one scenario. So here, what we first look at is to calculate using the 8 kilogram mass using a Newton's second law, and then we would give a mark for that formula. Either that mark would be there where we have F net is equal to MA, or if the learner is going to indicate that F net is T minus W is equal to MA, then that mark can also be given there. So you give 1 mark for either that formula, the first formula, or the second formula. The second mark will be for the substitution to calculate the acceleration using the 8 kilogram block. Now, because that answer will be taken forward to calculate the force using the 4 kilogram block, then we do not give a mark for that. That mark will be given for the substitution, for the whole substitution there, and the final answer will get a mark. So the total for, not for the whole substitution, I think I skipped that. There will be a mark for the substitution on the left-hand side, a mark for the substitution on the right-hand side, and that gives us a total of 5 marks. Yeah, that is about question 2, colleagues. The total for that question is 10 marks. I don't know, as Mr. Namani indicated, he said at the end of the question we could perhaps interact with the question or ask questions, but if there are no questions, then I will move to the next one.
And Tadeletina, 2.2, a colleague is asking, what if the learner did not say tension, but T1 and T2 to differentiate the 2 tensions that we have there on the free body diagram?
I'm looking at the memo. The one is, say, T1 and the other one is T2.
Yes, sir.
Or that could be T1 and this one could be T2. Colleagues, I think because we have really talked about this as the tensions and accepted that as, especially for F as the tension, I think we can give that learner a mark.
Thank you, sir.
Okay, thank you very much, colleagues. We can move to question 3. Question 3 says two metal balls A and B are rolling along in a horizontal straight line towards each other in a closed system. Ball A with a mass of 0.75 kilograms is rolling at a speed of 4 meters per second. Ball B with a mass of 1.25 kilograms collides head-on with a ball A at a speed of 3 meters per second. Now, after the collision, ball A rolls in the direction opposite to its initial direction at a speed of 2.5 meters per second. So that's the diagram, colleagues. Um, 3.1 says calculate the change in momentum experienced by ball A due to the collision. So you look at this question, actually focuses on the change in momentum. I think the idea here was to look at that uh, formula in Bobby Newton 3, where we would really encourage our learners maybe to have more understanding of that. So 3.1, what we have there is if we take that as positive, we'll take the change in momentum of object A because that is what we are asked to look at, the change in momentum of object A. And for that formula, we give 1 mark, and for the substitution, 1 mark. And then for the final answer, interpretation will be to the left or in opposite direction. So there will be separate marks for the magnitude and the direction. So that gives 4 marks. 3.2 says use the change in momentum of ball B to calculate the velocity of ball B after the collision. So we have found the change in momentum of ball A, and using that formula, then the change in momentum of ball B can be calculated. So we would give a mark for the formula. And then here, once the learner has worked out the momentum of change in momentum of object B from that formula, then they could use any of those options to find. I think it's just the change of direction to find the change in momentum of ball B, which in this case is we said we should calculate the change in, use the change in momentum to calculate the velocity of ball B. So the situation is that the learner should calculate the velocity using the formula. Change in momentum is given by final momentum minus initial momentum, and therefore the final velocity will be that 0.9 in the direction opposite to that direction. So you have 1 mark for that, 1 mark for the substitution, and 1 mark for the answer, including the direction as well. So this becomes 4 marks, 1 from the use of that relationship, and the other 3 marks for the calculation of that. This formula it's a bit, or this relationship, it's a bit challenging, and I think it's also a good idea just to introduce learners to it so that we can use it as I've tried to mention at the beginning of the discussion, that we can use this for teaching purposes so that learners can be aware that they can also have to use that formula and perhaps maybe practice more and more in order for them to do that. Now for option B, which was suggested by by some colleagues, we would still accept if learners use the conservation of momentum and indicate that the sum of the initial momentum is equal to the sum or the total momentum before the collision is equal to the total momentum after the collision. So I think the I have an example of how Elena did that. That was sent by a teacher. So the learner uses that, would give 1 mark for that, and then 1 mark for the substitution on the left-hand side, 1 mark for the substitution on the right-hand side, and 1 mark for the final answer with the direction. So I think that would be acceptable as well. So if a learner approaches it using that option, please check just that everything is done correctly. Otherwise, where there is a mistake, you will stop where that mistake is. For example, if in this case there was a mistake in, let's say in this substitution here, then you would get a mark for the formula, the mark for the substitution on the left-hand side, and the learner would forfeit the mark here because they made a mistake, as well as a mark in the final answer. So that learner would be able to get 2 marks. Question 3.3 says, what is the net change in momentum for the whole system? Ball A and ball B. What is the net change in momentum? And we said that the change in momentum is 0. 3.4 says, calculate the magnitude of the average force that ball A and ball B exert on each other during collision if the two balls are in contact for 0.2 seconds. So here we use the impulse momentum theory or theorem, wherein you could take you could use object A for your calculation, or you would use object B for your calculation. Notice that we need to mark positively from question 3.1, where we calculated the change in momentum, and also in 3.2, where we calculated the velocity. I think those are the situations, because we have, in this case, the momentum, and then for object B, we have that momentum and the velocity. I think 0.9 is there, it's included. So we need to mark positively from the previous question, which is question 3.1 and 3.2. So what do we mean, especially for colleagues that have not, marked before? When we talk about positive marking, if I want to refer back, maybe even on this one, if we have positive marking and that positive marking is within a sub question like 3.2, this this one will not be so appropriate because now there's no calculation here. I wanted to look at this one. If the learner for this question had calculated the acceleration wrongly, then we would continue with that answer that the learner has got, which is a wrong answer, substitute it in the next step for that particular sub-question. But because there was a mistake in the calculation there, this learner would be marked positively with the substitution of the answer that they got there, which is may not be 5.2. But this learner will not get the answer correct. So that learner will forfeit a mark for the answer. That is positive marking within a sub-question. But if we have positive marking, like in this case, it's from 3.1 to 3.4, then what happens is that we mark the learner with the error that the learner has made. I'm looking at the velocities. If that learner had calculated the velocity wrongly there,
I'm sorry to just
then
come in, like it's
sorry,
bad
in 3.1,
or is it
then the
maybe the
velocity
audio
that
is
the
just
learner substituted in 3.1
hearing
would
you?
still be marked correct based on the correct substitution in 3.4. Then that learner will continue with the error up to the final answer. Now, what we normally do would be to take a calculator, calculate the value of the final answer that the learner has got based on the wrong on the substitution that he made with the wrong calculations. Then if the calculation, the final calculation is correct according to the figures that the learner has used, then the learner will get the full benefit of or the benefit of the full marks for that question. So if it is positive marking from 3.1 and 3.2, then this learner, because it takes the mistake from one subsection to another subsection, then for that subsection, this learner will get a full marks. That is positive marking within a question. But if it is positive marking within a sub question, then the learner forfeits a mark in the final answer. I think that makes that is clear to colleagues, so that we can, at the same time be able to empower one another. 3 point. Yeah, I think this question is straightforward. It's 3 marks. So it's 1 mark for the formula, 1 mark for the substitution, and 1 mark for the final answer, which in this case should include the interpretation, because I think the question said we should calculate the magnitude of that. 3.5, is the collision elastic or inelastic? Explain the answer by means of calculations. Colleagues, I think for the whole of last year, this question has been stressed that learners should be able to do calculations in order to be able to justify whether a collision is elastic or inelastic. And in most of the discussions, we really expect the learner to write the answer after the learner has made calculations. So the idea is that the learner should be able to calculate the total kinetic energy of the system before collision, and then calculate the final total final kinetic energy after collision, and then compare the two. If the two are equal, then we would say that kinetic energy or total kinetic energy is conserved, and therefore the collision is elastic. If the two are not the same, as in this case, the initial total initial kinetic energy is bigger than the final total final kinetic energy, then we expect the learner to say it is inelastic because the initial um, total initial kinetic energy is not equal to the total final kinetic energy. Or they can say the final kinetic energy, total final kinetic energy is less than the total initial kinetic energy. Colleagues, you will also check, I think there was also a calculation error there that has been corrected, but in principle, um, we did not award a mark for this final answers, but we looked at, for 5 marks, we looked at the formula. We marked that formula either there or there, just 1 mark for the formula, then 1 mark for the substitution in the initial kinetic energy, then 1 mark for the substitution in the final kinetic energy, and then 1 mark for a learner indicating that the collision is inelastic, and the final mark for the reason. A question that has popped out um, a number of times would be if the learner then starts by saying it is inelastic. Okay, that latency, I think we'll see. I think here we might still give them the mark if they say inelastic and mark it separately as it is. But if that learner starts with, perhaps I should have indicated here, if the learner starts by saying that the total kinetic energy before or initial is equal to the total kinetic energy after, then that is a wrong assumption because the learner has not yet determined whether this collision is. So in that case, then we would penalize a learner that mark or uh, that mark for, or 1 mark, would remove 1 mark for just wrongly assuming that the total initial kinetic energy is equal to the total initial, because the learner at the moment does not know whether the collision is elastic or inelastic. So if the learner equates the two, then it implies that the learner is saying the two are equal, and therefore the collision is elastic. So I think that should be approached that way. If they use EK final or initial is equal to EK final, then for that you can mark the calculations and to say that it is inelastic, but then we will remove a mark for saying that the initial and the final total kinetic energies are equal. So that learner would get a maximum of 4 marks out of 5.
Thank you very much, and Tina, for question 3. I have few questions that colleagues are asking in the chat. But before I can attend to that, colleagues, just a quick reminder, kindly keep off your mic off, and your videos should always be off at all times. Austin Kolani, kindly switch it off so that you can save the bandwidth thereof. The first question, Tina, is on 3.1, and Taitsan is asking here to say it was not indicated for west, east, or north, such things. So if the learner did not say left and used west, can we award a mark for that? That is now at 3.1. If the learner
Okay.
said west instead of left, should we give that learner a mark?
I think my take here uh, would be that normally the marking, it's true, it's not indicated in the question here, um, but we look at the wording in the questions. In this case, we are told that the ball rolls in the opposite direction to its initial direction. So I think that is why we opted for the answer referring to the initial direction. It will be in the opposite direction or in that direction. So if it had been indicated in the question that it's moving east or it's moving west, then we encourage learners then to use the directions indicated in the question. So I think in this case, we should, so that we can go back to the learners and make them aware of such things, that when marking is done at the end of the year, they should be, those are some of the pitfalls that they can be caught with. So let's perhaps stick um, to
The marking guideline.
to and yes. Actually, I think a opposite direction would be more appropriate even to say left and right in this case.
Thank you very much, Tina. So if the learner said west, we do not give a mark. We only
Please.
accept left or in an opposite direction. Furthermore, for 3.2, is the final answer for the answer with the unit or the answer with the unit and the direction? That is now for 3.3.2.
3.3.
Yes, is the final mark
Is the yes.
is the final mark for the answer with the unit or the answer with the unit and the direction?
Uh, uh, Generally, as a principle, um, the final answer is taken to be correct if the unit is there. Without the unit, the magnitude of the answer is not a awarded mark. So this mark then includes the answer, which is the magnitude, and the direction. So if we say the answer, then it must be, because in the final answer, there must be a unit.
It basically says the mark is only allocated provided that the answer is correct with the SI unit
And the direction.
followed now by the direction. So colleagues, it's
Yes.
the three things that we need to consider now for 3.2. 0.9 with the correct SI unit and the direction thereof. The other one that day is from Meshwani. She's asking here, if the learner did not square the velocities and continued with substitution and the kinetic energy is not conserved, how many marks? That means now that is for the question on elastic or inelastic. So instead of the learner saying the sum of EK is equals to half mv squared, the learner omitted now the squares but now continued obviously to get the value of the sum of kinetic energy before as different from the sum of kinetic energy final. So but now without squaring the formulas
Okay.
for the velocities for kinetic energy.
Okay. Let's start here first. That if the colleague is able to, uh, is the squaring or uh, the exponents there left out in the formula
Yes,
or in the substitution?
in the formula. Let me check.
Yeah, because we
Continued with the
then we write
substitution and the kinetic energy is not conserved. how many marks can be awarded. So I think it is in the substitution.
Then if it is in the substitution, I will just draw from the experience that we have. And I didn't see you, I hope you are around and you can also guide here. But if the learner did not square the in the substitution, then we can penalize that learner a mark for not squaring that uh, substitution. But really, it would not be correct to penalize the learner twice. If we have penalized in the first substitution, then the learner may not be penalized for the second substitution because that is a mistake that they carried uh, 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 through here. And I mean, we could not correct the learner then, but then. It means then the learner would forfeit a mark for that. In that case, if that was correct, I think we could then take only one mark for that. Now it leaves me with a dilemma there that if the formula is wrong, whether we call that omission or not, because if the formula is wrong, but there's that omission. I think here maybe we can come up with an agreement, colleagues. If a learner does not square in the formula, then that makes the formula wrong. Perhaps what I would suggest is that if they have not squared in the formula, then that makes the formula wrong. So the mark for the formula will be forfeited. Normally, if the formula is wrong, really the substitution will be wrong, and there's nothing we can do about that. That would lead us to penalize the learner twice. But we can give for this part because now the learner cannot fulfill all the 5 marks. So if the Titabang, you'll come to my assistance there, but this is how I think about it. If the formula is wrong, then the learner can forfeit these 2 marks, but we can continue there. Not the formula being wrong, but the learner having not squared there, because it could be just an omission. But that would be a wrong formula. Unlike if maybe a learner uses a momentum formula and you know that learners sometimes use change in momentum or total momentum is equal before is equal to total momentum. So in that case, then it will be a completely wrong formula. Then we can only award for the inelastic, and it will be 1 mark. But if it is an omission like that one, I think we can take a mark for that. But if the learner continues squaring there, because the formula is wrong, then I think we can take the 2 marks, which might sound a little bit strict, but it is because it's based on the formula not being correct. I don't know, maybe colleagues can come up with a suggestion there, but I think for not squaring in the formula, then I would really definitely take the 2 marks. But for squaring in the formula and eliminating this, I would just remove 1 mark and continue with everything. But if the formula completely is wrong, like total momentum before is equal to total momentum, unfortunately, then I will forfeit the marks for the calculations only for the inelastic. Um, but he cannot talk in terms of kinetic energy if they talked about momentum there, so it would be 1 mark.
Yeah, that Latina, thank you very much. And that NCA apparently is in the meeting, but apparently cannot be able to use the
He's
mic or something like that. But
okay.
I got some information where he says we can accept West. Lintate Sifo is
Okay.
also saying we can accept West because also left is for 3.1, that is
Yes,
uh,
yes.
left is also not in the
In the
question when we are
okay,
told that now the
okay,
object is moving towards the right. So for that we can
okay.
accept west, We can accept left as well as in an opposite direction.
No, thank you very much, colleagues. No, I have no a problem with that.
Okay, and that now answers the question that we had of Omacheta saying that now the examiner also did not say left or right. And we have a hand from Mr. Numalo. So, Mr. Numalo, if you can just switch on your mic, then maybe ask the question that you have. And Mr. Numalo, before I give it over to Ntate Taitsani, okay, the hand of Mr. Numalo is no longer there. Let me give it to Ntate Taitsani.
Good morning, colleagues.
Morning,
Good
Ntate.
morning.
I want us to go back to question 3.2. And then again on question 3.2 there, I just want to find out whether Elena would be penalized if Elena omit or did not indicate that step that started with the change in momentum of P is equals to the negative change in momentum of A. Elena does not show that step at all. But Elena moves straight and start with the change in momentum of P is equals to M in bracket final velocity minus initial velocity. But now Elena substitute correctly the change in momentum of B by understanding the relationship between change in momentum of P and A. Thank you.
Thank you, Ntate Taitsani.
Yeah, I think it will go back to just the relationship there. So you can just penalize for that relationship, and Elena gets the marks for the part where they have done right. That would be my take.
Thank you very much, Ntate Litina. I think we have exhausted question 3 colleagues in detail. Mr. Bernard Oseye, please switch off your camera. You are the only one with the camera on. And Ntate Litina, with that being said, I believe we can go to question 4, sir. Thank you very much.
Thank you. Now. I'm just making a note here. If you can, colleagues, excuse me for a minute. Question 4, colleagues. Um, 4.1, colleagues, says the graph below shows the velocity time graph for the ball that is dropped and bounces ignore a resistance. I wouldn't go to that statement, but it could be something interesting to talk about. The learners arguing about that. 4.1.1 says define the term projectile, and I think in the memo, it says an object which has been given an initial velocity and it moves under the influence of gravitational force only. And I wonder why this time the marks are not given there, but we can give that. The object which has been given an initial velocity and then it moves under the influence of gravitational force. I think we ought to have underline perhaps that it moves with it's given an initial velocity and it moves under the force of gravity. But this, I think, according to how we plan the most important can I say keywords there is that it's influenced by gravitational force only. So perhaps we can make it a true or zero if the learner has not mentioned that it is acted upon by gravitational force only, then we can make this a true or zero. colleagues, you are free to object to that. 4.1.2 says, describe the motion of the ball between points A and B on the graph above. The object here between points A and B, I think this also takes its origin also in equations of motion in grade 10, where I would say that the acceleration is constant if we have a straight line velocity time graph. So that means that the object or the ball is moving with constant acceleration, and that is what is expected there. Uh, 43413 says, from the graph, determine the direction in which the ball is moving between points C and D. Between points C and D, if maybe we can talk about this, the ball is dropped and from a height, and its velocity increases to 8 meters per second there. That is the velocity with which it hits the ground, and it bounces. And it bounces with a velocity of 4 meters per second. And then it goes up again. So between C and D, the ball is actually moving. Between C and D, the ball is actually moving up to where the highest point there, then its velocity will be 0. So what we have there is that the object or the ball is moving upwards between point C and D. Now in 2 it says determine the number of times the ball bounces, and in my description there I said the ball is dropped and hits the ground and then it bounces. So there are not many bounces here, it's only one bounce. So there it is. And then the next question says, from that graph, determine the time at which the ball is at its maximum height. The time at which the ball is at its maximum height is 1.2 seconds. That is when its velocity there will be 0. And then, so all these are just 1 mark each, colleagues. Now 4.1.4 says, explain why the velocity at C is less than that at B. Why the velocity at C is less than that at B. I think that this it's interesting to note that the ball hit the ground with a velocity higher than the velocity with which it leaves the ground. So a learner needs to ask themselves what could have happened there. The energy with which the ball leaves the ground is certainly lower than the energy with which it hit the ground. So some of that energy has been lost. So we thought perhaps learners would really struggle with talking about deformation. Hence why the idea here was maybe this can be split so that disadvantage learners as such. But I think the idea behind that is for the learners to realize that as that ball hits the ground and bounces, it does not rise to the same height because some energy is lost in the process. So at least for the energy loss, they can be able to get a mark there. Okay, yes. Perhaps we can check if there are questions for 4.1 that
Thank you very much, Ndadeli. There are quite a few number of questions. The first one is from Marianne Smith. It says, if a learner describes movement according to initial and final velocity and the position of the ball and not referring to the constant acceleration, how do we address that one?
the learner refers to.
The learner describes movement according to initial and final velocity and the position of the ball, not referring to constant acceleration. That should be for
I wish
4.1.
I could. Yes, I wish I could. Understand that. But as I have indicated, colleagues, this goes back to the equations of motion, the motion in grade 10. And then there are areas where learners have to describe the motion where there's constant acceleration, there's um, 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 constant velocity, or changing velocity. So I think the idea would be there. So if the learner talks about the position and stuff like that, I wonder how the learner would have put it. Colleagues perhaps can come in there, but I think I would look at the way we would be expecting them to refer to this in grade 10.
Yes, because what I said to Mem is kindly share an example of how the learner wrote it. Okay, this is what she says.
Mm,
The
mm,
ball
mm,
is let
mm,
go with initial velocity of 0 meters per second and hit the ground at point P with final velocity of 8 meters per second. That is now an example of how the learner actually answered or described the motion of the ball between A and B. So ball
the ball is
is let go with an initial velocity of 0 meters per second and it hits the ground at point B with final velocity of 8 meters per second without
mhm.
stating anything about constant acceleration.
Wouldn't this be a good point, maybe, because we may also remember that these learners in grade 10, maybe some of this, especially this topic on motion, I think it was somewhere towards the end of the year, that perhaps maybe this would be an opportunity, as we have indicated, that as teachers we also remind these learners about such descriptions of motion. I think for me it would be more about taking the question back to the classroom and then trying to link it with the motion in a straight line in grade 10. Um, so in that answer that the learner, I know it might be a bit tricky. The learner has, I just want to check the, the question, describe the motion of the ball between the learner says it starts with an initial velocity of that, and then it hits the ground with a velocity of that. That is correct, but it does not show whether, uh, because this is a straight line. I think the key thing is that it's a straight line, and the straight line shows the 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 relationship between the velocity and the change in velocity and the change in time. And I think that constant acceleration is quite important. I'm just trying to check now that it is 2 marks. Although I would want to stick to saying that let's stick to that, because that's how we describe motion in grade 10 and in grade 10. And perhaps let's go back and just polish that.
In this instance, the learner will get 0 because of not
No,
explaining
I
the
think so.
relationship in terms of
Yeah,
constant
yeah,
acceleration or the gradient
yeah,
thereof. Thank you very
yeah.
much.
No, and let's put
Thank you very much, Dadeltina. There's another one from Alta. I think it's the same thing. How many marks if a learner started the ball from 0 to meters per second in a positive direction? We agreed that it should be 0 because the key thing, or what the examiners were trying to assess, is actually the relationship in terms of the gradient of the velocity versus time graph. And I have another question here at 4.14 that is now from Van der Roos. Can a learner be awarded a mark if he said the ball lost momentum? That is 414. Instead of saying energy is lost or in deforming the ball, the learner said now it lost the momentum. Can we award a mark for that? 414.
I'm quickly looking at the formula there. They both involve the velocity. I think I stand to be corrected, but I think we can give a mark for that.
Okay. 414. To answer that, so you are saying that Deltina for 414, if the learner says the ball lost momentum,
So,
we can give a mark.
yeah, I think we can accept it, not necessarily. Yeah, I think we can accept it. Unless colleagues you have, but the correct answer there should be that it is lost energy, but perhaps colleagues can come in and if they.
From okay, I will summarize it up later. I have now
Okay.
two hands. Maybe they are addressing the same issue of 4.14, and then we'll go back to Ndatetsa for something. David plus Alta Fori, you can open your mic and ask your question or a comment.
Yes, I want to comment about the momentum part. Momentum is conserved, energy can be lost. You remember
Okay.
that part, yes.
Yes.
And then I asked, my question later on is, I ask if a learner says energy is lost due to heat and sound, instead of saying the required
In-
answer there.
In
Thank you,
deforming
I'm
yeah,
going
in
off.
deforming the ball.
Yeah, instead of
yeah.
saying deforming, but heat and sound.
I think that would be correct, man.
Thank you, I'm going off.
Yes.
Thank you, Alta. So I was also going to say momentum is conserved,
It's
but
considered okay.
energy
Thank you.
is not conserved. So we cannot
It's lost.
accept if a
Yeah.
learner said
The momentum.
momentum. So it should
Thank
be
you.
in relation
Thank
with
you.
kinetic energy thereof.
Thank you. Thank
Let
you.
me go to Tate Lekgowa. Your hand is up, Ntate Lekgowa, or is it an old hand? If so, then let me check what we have in the chat. We
Thank you, Mr. Nambani.
okay, thank you, Ntate Lekgowa.
I just wanted to find out 4.1.2, if the learner said free fall, do we award a mark or not?
4.12, if the learner said
It's a free fall.
it is a free fall.
Oh.
412, it is moving
Yeah,
with constant
yeah.
acceleration.
Because we know if an object is free falling, the only force acting there is gravitational force, meaning the object will be accelerating due to that gravitational force acting on that object.
Yeah, true.
And
Uh,
there's constant
and
acceleration.
it is constant acceleration.
Yes,
Mm.
yes.
Yeah. And Tatel Tina, do we accept?
I think I agree. I think we can accept that.
I believe we can accept, colleagues. So 412, if a learner says it is in a free fall, then we should now give a mark. Thank you very much, Ntate Lekgowa, with that input. The last, yes, sir.
It's Mr. Moreng here.
Hello, Ntate Moreng.
Uh,
Your line is very bad, colleagues.
I was asking if you can for.
Can
That
you
number, can you hear me?
your line is very bad, sir.
Can you hear me?
Can you kindly type it in the chat or send direct message to me, because now your line is very bad. We cannot hear what you are saying. Please just type it in the chat. While we wait for that question, isn't it better at, this is now from Rihanna Race, isn't it better at 414 to say energy is converted into other forms? 414.
Yeah, I think when I explained that, I said perhaps it would rather be a challenge for a learner to say energy is lost in deforming a ball. So if you can repeat that statement, energy is converted to other forms.
Yes.
Um, um, I think it's like the lady who has just asked about energy being transformed to heat
Yes.
and sound.
I also believe
Yes,
the key idea was the intention of asking this question
energy is
was basically energy is lost, and in which sense. So
yes,
if there's any form of
yes,
indication in terms of why is it lost or is it not conserved, then I believe that learner should get a mark.
yes.
Yes, and I believe that the Latina, the last one is, are we not being harsh by applying principles of 2 or 0 for definitions in one question? Mema Shwani, this one, it's a standard rule in a way that we need to prepare them and coach them to say definition is 2 or 0, and all the keywords should be there. So it's not necessarily us being harsh, it's just the emphasis of definitions are very critical. With that being said, I don't have anything on my side, Tina, so you can continue now with 4.2. Oh, there's a hand quickly, Taitsani.
Morning once again, colleagues. Ntate Nambani, you have not yet addressed my question on 4.1.3 on the chat. Thank you.
4 point.
4.1.3 on the chat.
Can you kindly say it already, Menir, because you're on the platform? I should have missed it. I'm so sorry.
Okay. What we wanted to know is that for 4.1.3C, can we accept the time t being 0? Because the question never says after the first bounce, it just says the time the ball is at maximum height. Thank you.
Latina, the
So
question,
can we accept what?
T is equals to 0.
Okay, the ball.
That C is equal to 0.
No, T is equals to 0 at, let me check my question paper also on this side.
Okay, okay,
It says 413, from the graph, determine
okay.
the time at which the ball is at maximum height.
Yeah, no, that one is technical. It's technical because anyway, that is correct. But you see, the technicality here is that one would not say after the first bounce, because in a way one would be giving away the answer to how many times the ball is bouncing. Uh, so um, um, that is the height from which it is dropped, and that is its maximum height. Uh, you, you. What can I get perhaps because technically that is correct.
I think there's
Yeah.
a follow-up from Tate Taizan, and then I think we
Yes.
can close it off.
Yeah, yes, Dr. Nambani, because the question there it says from the graph. So a learner would be interpreting that question based on the instruction given to them. It says 4.1 it says from the graph determine, and then the question follows. Time at which the ball is at its maximum height. A learner can use
Yeah.
any.
Very true.
Yeah, perhaps, yeah, yeah, I think maybe we could have set maximum height from the ground, perhaps, but still, it would be, yeah.
The suggestion
Do you have a learner that has answered like that, Nade Teza? Or are you just challenging that question on that basis?
No, I do have some responses, and a quite number of them that indicated zero.
okay. And Tate Taizan, let's allow us to engage with Tate and Zie as the chief examiner for this particular paper, or the internal moderator. Then kindly wait for the errata, because we'll be sending out a new memorandum with all these inputs. Let's not take immediate decision. Maybe there is a way of us addressing that particular issue, because I think the question wanted now to check the understanding of the learners, but it somehow became vague, because zero, I think,
Yeah.
can also be an acceptable answer. So allow us to have that time, and then we share it with Datenzie, and then he will come in and assist in that regard. I noted that Mr. Pinar, you also have a concern about that. So colleagues, I will take it further with Datenzie, and in the errata it will be accepted. Thank you very much,
Yeah,
Ntate Tina. I think we have exhausted all the questions that we had, so we can continue, Mania.
yeah. I think also maybe that's why we can also go back to as we discuss with learners, what the idea of the question was about, and see if yeah, because I think really that is highly technical, and it's understandable. Question 4.2. Says a ball is thrown vertically upwards from the balcony of a tall building with a velocity of 12 meters per second. On its way up, the ball passes a window which has a height of 1 meter. The balcony is 4 meters above the ground. The velocity at the bottom of the window is 8.1 meters per second. Colleagues, I think when we come to this question, there was rather a lot of concern about, the question itself. But in particular, I want to move to question 4.2, in particular point 2.3, that last bullet there, which says the learner should draw a velocity time graph for the motion of the ball from the moment that the ball is thrown upwards until it comes back to the position it was thrown from. Then it says use the point from which the ball was thrown as a reference. And then that last bullet says the velocity with which the ball should be indicated on the graph. Firstly, I would like to make a comment that this actually is a very good question. And I would therefore appeal that the intention for the question is a good intention and a good question. And this question is going to help us if we can look at it from the positive side, despite the technicalities with the question, that it could give us different scenarios that we would deal with when we teach learners. So my appeal to colleagues about this, because as far as the marking is concerned, the question is just a question of 1 mark that needs to be dealt with. But in terms of the lessons that we can get from the question, it is a brilliant question. We can be able to look at the motion of the ball in that trajectory where we have a parabolic trajectory, and we can be able to use several points to calculate, including, for example, the final velocity with which the ball hits the ground. So all those scenarios can come. So I would appeal that we approach this question with an attitude that we can be able to go back to the class and use this question to explain a number of things, and also to expose learners to the different scenarios. Now, question 4.2.1 says define the term free fall, and the learners are expected to say that free fall is motion under the influence of gravitational force only. And I think that is very much similar to that. I think that is why I was looking at the 2 or 0. It's similar to that. Or learners can say motion during which the only force acting on the object is gravitational force. 4.2.2 says calculate the time taken for the ball to reach the maximum height. I think from the question, learners would be able to calculate the time taken to reach the maximum height, because they know the initial velocity of the ball, they know the acceleration, and they would say at the maximum point, the velocity of the ball is 0. So they can be able to calculate the time. So using any formula that has a time there, in particular, this formula I think would be the easiest to use, and they would be able to substitute. So they get 1 mark for that, 1 mark for the substitution, and 1 mark for the answer. So that makes 3 marks, and that is clear. I hope a lot of learners have got that right. The second one says calculate the maximum height reached by the ball. Here the learner would use the equation with the distance or the change in position. Or if we want, we can say with delta y, and then use the formula. There will be 1 mark for the formula, 1 mark for the substitution, and 1 mark for the answer. Colleagues, we thought about this and said then that because the question mentioned that the balcony is 4 meters above the ground, so it would be proper to indicate that the maximum height actually is the calculated value there plus the height from the ground. So although we are not going to award marks for this, we'll just award marks for that calculation. But I think, like I indicated, let us use this question to interact with the learners and show them the correct principles, because we have had quite a number of questions that stress on the maximum height, and learners have to add whatever the height they've calculated of the ball to the height above the ground. So that, I think, is a point for discussion with learners that you can also bring in there, because in the final question paper, for example, they would be looking at that, and so we need to discuss that as well. But for the marking, I think based on the mark allocation and that, we would just stick to giving the marks to that and leave out that, although would encourage you, that is why we included here that for the maximum height, let us please go and address that with the learners as well. And then you'll notice also, colleagues, that you can also use this equation, although in most cases, because of the fact that it does not have acceleration, sometimes it has its own challenges, but you can use that equation as well. You'll be able to get to that answer. So if the learner uses any of these equations, then we would be able to award a mark. So our idea in this case, in a marking question, is that we should just award the 3 marks, and then I think much as this is correct, we can just explain it to learners, but that would not affect their marks. And I hope a number of learners have really managed to calculate that. The idea behind this, actually, as I've indicated, would be we would actually talk about the complete motion of this ball, but in this particular case, we're just focusing on the upward motion. That is why I'm saying it would be very interesting if we would look at the various scenarios as well. And the third question there says, or the third question says, calculate the time the ball takes to reach the top of the window. And this, to eliminate a number of things, colleagues know, it says on its way up, the ball passes the window. So in this case, we're just focusing on the movement of the ball upwards and bringing into context the fact that the learner should be able to calculate a certain section of or use a certain section of the motion of the ball to be able to do calculations. And this would be the type of a ticker tape timer kind of question. So I think that was the idea. So I think these learners would be able, and hence why we realize that this statement, the velocity of the ball at the bottom of the window, is needed to be included in there. So I think learners have been able to calculate that from using this equation, I thought this would be the point to start from, because they would have to know the initial velocity at the bottom of the window there. But for that, yes, they are given that initial velocity. They don't know the velocity at the top of the window, which is, I think, is what is needed. And they know that this ball is going to pass the window, because the maximum height has been calculated there as 7 point something. So we expect then that these learners should use that information to calculate the time that the ball takes here. So the starting point would be to use this equation. Notice that I think, for the fact that already we have used the equations of motion and also considering the marks, we thought, no, let's just give the mark, not the equation, give the mark for the substitution there. And that also points to that positive marking that we talked about, that with the answer that the learner gets there, then the learner can now use an equation which has time or delta t in it, so that they can be able to get to the final answer for that particular section of the graph or of the question. Now, like I indicated, the challenge was here really with 4.2.3, the last one. But this says draw a velocity versus time graph for the motion of the ball from the moment that the ball is thrown upwards until it comes back to the position it was thrown from. Use the point from which the ball was thrown as reference. Now it says clearly indicate the following on your graph. Colleagues, I think it would not be a problem for learners to draw the velocity time graph indicating the velocity with which the ball was thrown upwards, which is 12 meters per second. We would know that that is supposed to be a straight line. So they would have the velocity with which the ball is thrown. And then the second bullet says the time taken by the ball to reach the maximum height. That, I think they'd calculated, they would be able to do that. Now for the 1 mark that I referred to, they have to indicate the velocity with which the ball arrives at the ground. In our discussion after this, you will see that this memo now with what we are suggesting has changed, because the feelings that the learners should have answered this question, in which case then they would be saying, okay, the ball bypasses the point where it was thrown from, and then it hits the ground. So the velocity there should be on the ground should be higher than the velocity, the initial velocity, the velocity with which it was thrown. So then we thought, perhaps to accommodate this learner's answers, then a learner should understand that this part of the graph, that second part, should be longer than the first part. And I think if we would do that, then we would address the situation. But on the other hand, I think this also gives us an opportunity then to say, how would the graph be if we would consider the motion of the ball from where it was thrown back to, up and then back to where it was thrown, where the velocity at that point would be equal to the initial velocity. So this is a brilliant question. Please, let's use it in the class. We will see how we can work on the technicalities that we found. But at this question and the intention behind the question and the way the question could be used, he can also use it in his presentations in his channel. So I think it can give us a lot of opportunities to interact with it and to explain the different scenarios with our learners. Thank you, Nadina Mbani. I think can get questions if there are.
Thank you very much, Tati. There's a hand from Tate Moreng. Tate Moreng,
But
good day, sir.
number I was asking with regard to 4.4, 4.1.4.
4.1.4.
That number
I'm with you, sir. 4.1.4.
4.1.4, yes.
We are listening, Menir.
Number.
We are listening, sir. You can go ahead.
That number, can you hear me?
We can hear you, sir. Go ahead.
Yes, I was asking, instead of saying the energy is lost, how about we say the kinetic energy at point C is greater than the kinetic energy at point B? At B is greater than point C. Instead of saying the energy is lost, because the law of conservation of energy says energy cannot be created or destroyed.
So in simple terms, the right wording should be energy is not conserved.
Yes, you can say energy is not conserved other than saying energy is lost.
I believe we can also accept that, Menir. Thank you very much.
Yeah.
Then I also wanted to ask with regard to 4.2.2, the last one,
4.2.2,
common figure number 3.
Roman figure number 3. Okay.
If the learner did not calculate the final velocity with regard to it's option number 1, 2, and 3, the last option, the learner went straight to that calculation, which does not require him to calculate the final velocity. Where are we going to award the last mark? Because it's 4 marks.
If the learner used which one that they number?
Delta y is equal to vt plus half a delta t squared. That one does not need the final velocity.
Okay.
So the question is the mark for that first block
For
where,
that,
where they
if
calculate.
the learner used this.
Yes. So how do we give the learner the 4 marks, because eventually the final answer is correct and
Okay.
it
No,
doesn't require
yeah,
the calculation of final
yeah,
velocity.
yeah. No, let's. I think you made a good point at that point at some stage that okay, let's think about it and see how best we can allocate that mark, and then it will be included in the final.
Thank you very much, Ndati. Mr. Moreng, the memo will be updated and then it will be indicated where now the other mark will be given if the learner did not now attempt to do and calculate for the final velocity. Thank you very much. Ndate Sello Emmanuel.
Morning, Dr. Nambani.
Morning, sir.
Yes, I just want to ask the question in 4.2.3.
4.2.3.
Yeah, on the graph.
Yes, that is it.
So based on the last bullet set, or the last bullet that said, the velocity with a ball arrive on the ground. So some of the runners, they calculated that particular velocity. They indicated the initial velocity where this particular ball started to move vertically upwards, and the final velocity when the ball hits the ground. So meaning that particular runner indicated the velocity of 12, and negative 19 point, I don't remember exactly the value, 19 point something, negative 19.35, if I still remember exactly. So in that particular, if that particular learner did that particular thing, so how do we allocate the marks? Because the marks are 3 for indicating the final velocity and
Initial
initial velocity and the final
velocity.
velocity of, yes. But that particular learner, he calculated the final velocity based on the last bullet.
Yeah, yeah. If you allow me, I think, like I said, it's a question of also engaging with the learners. That learner, of course, would be correct to show that the velocity is it's greater than 12, the initial velocity. But now you go back to that learner and you indicate that this requires just 1 mark. And I can assure you the calculation involving the final velocity there, it requires more marks than that. So I think that is where, as teachers, we would, show our learners that, because there's nowhere where these learners have been asked to calculate the velocity with which the ball hits the ground, then they would probably look for something that would be equivalent to a 1 mark.
So
So if the learner have a calculation there and then indicates that the velocity is I don't want to say bigger than, but well, because this negative is just for direction. Let's say it's bigger than 12, then but based on now, if we would look at positive marking, but there is no way where the learner had been asked to calculate that. But we can award if the learner has indicated that this velocity here is bigger than that. Perhaps that is what we can look at in the last bullet there as well.
thank you very much, Tina. To maybe summarize for Silo, what you are saying is, because learners were not asked to calculate that final velocity and they went to calculate, as long as all three bullets are being met, in a sense that the last part of the graph is longer than the first part, that means it has passed now the negative 12 or the 12 meters per second, then definitely that learner should be awarded full 3 marks. That is what I am getting from you, Menia. Thank you very much. There is a question from Khadebe Nzima. Says question 422, number B. The question is not specific whether the maximum height should be from the ground to the balcony. So many learners calculated from the balcony up, so they finished up until 7,34. What do we do in this situation? Maybe I should repeat it for you, Dade. The question was not specific whether the maximum height should be from the ground to the balcony. So my learners calculated from the balcony up, so they finished up until 7,35 meters. What do I do in this situation? So they did not add up the 4 meters to get 11,35.
Yeah, I think the colleague has just arrived, probably, or missed that part.
Yeah.
We said the decision we take would be this: we discuss with them. We discuss with the learners that the correct way would be to do that. But then, for their benefit, let's just give them the 3 marks up to 7,35.
Thank you very much. I believe the colleague just joined that day. So that day, Khadebe, we just mark until 7.35, but the emphasis will be now the addition of 4 meters. Menir, I don't see any hands. I don't see any messages. You can kindly and freely go to question 5.
Thank you very much, Nadenanda. Question 5. Oh, already have addressed that in the Africans version. So I think that will be. So question 5 says A to F in the table below represents 6 organic compounds. They are given their colleagues. 5.1 says write down in 5.1.1 the letter that represents 2 organic compounds that are isomers of each other. And the compounds that are isomers, in this case, B and E. And then the memo here says the learners should identify both compounds and they should be correct for 1 mark to be awarded. So because this is just 1 mark, I think it makes sense because what they cannot be isomers if they you only have 2 compounds. You cannot say B is an isomer or E is an isomer. 5.1.2, the type of isomers, whether it's chain, functional, or positional, identified in that. We have said this is chain isomers, and the suggestion was that because already we have talked about isomers, types of isomers, then that mark really is just for chain. Not necessarily. If a learner leaves out the isomers or just says chain, you give that learner a mark. And 5.1.3 says the general formula, or write down the general formula of the homologous series to which compound D belongs. The general formula for which compound D belongs. This is a carboxylic acid. And so the general formula for carboxylic acid is that. And I think that is straightforward. Learners have to know, in this case, the general formula of different homologous series, but we can also accept if this is written like that. Five point 1.4 says name the functional group of compound C. Name the functional group of compound C. This is a formula group. Colleagues, I don't know, I really, sometimes you just look at that and immediately you get the answer and you think of the answer and this was really very interesting and I laughed at myself for having said that it's a ketone or a ketone. So the correct answer there should be the formula group. And to start with, even saying the ketone is not the name of the functional group, but rather the homologous series. So just laugh with me, colleagues. 5.2 says write the IUPAC name of compound B. 5.2.1, the IUPAC name of compound B. The IUPAC name for that compound will be 2,2-dimethyl X3E. I think we've tried to break this into 3 parts. That it must end in ENE because it's an alkene.
And I
Did I say alkene? Oh. Yes, mate. Is there a question?
We'll take questions when you are done, Menir. Continue.
Okay. You look at that. The okay here then if that is correct, I will have to look at that. But it looks like it is an alkane. I will check that, colleagues. It could have been a serious compound B. Let's look at compound B. Yeah, this looks like an alkene. We'll check if we expand the structure, but the memo says it is 2,2 dimethyl hexane, X3. So to give for the dimethyl a mark, for the 3-hex in a mark, and then for the functional group a mark. We'll have to check this, colleagues, if it's not. I think I might have made a mistake there. Colleagues, you can check already. The IUPAC name of compound F. Compound F is the alkene is this one with the double bond. Should be 2. Oh yeah. No, yeah, I think I made a mistake. The one that is, this one is 521 is an alkane. From that structure, it shows that it is an alkane really, because this is a straight chain, or it could be, but I looked at the wrong compound. I was worried by that because the alkene is compound F with a double bond, and then there are 2 methyl groups, and there it goes. So we would give a mark for this one, but for pentane, it's just a straightforward answer. For this one, we would look at the functional group, which is an alkene, and then the methyl groups are attached on the second carbon atom, and then it has 6 carbon atoms, and it's hex 3e. Colleagues, I know you know this, but it also if we could also use ChemSketch, it helps us to come up with the names of compounds. At times, if you have time to draw the structures, you can be able to come up with the names of different organic compounds, and you can use that ChemSketch also to help your, to make activities for your learners so that they can get familiar with the use of the rules to get the names. I'm sorry for confusing 521 with 522. 5.3 says write down the structural formula for compound A, and that is the one that we referred to earlier. So I think it is like that. The functional group, which is a triple bond, should be in between the 3rd and the 4th carbon atom. And there are 3 methyl groups, and then check that the structure is correct, and then you give the 3 bonds. So even for the Africans, I don't think it makes a difference. Okay, thank you, Ladenamba.
Thank you, Ndatelechina. 5.13. If the learner wrote CnH2nO2 instead now of CnH2n plus 1 plus Q, can we accept that? That one
The
is
learner writes C.
Cn H2N,
CN
H2N,
H2N
O2.
plus 1.
No, without the 1.
H2, CN
CN,
H2,
H2N,
uh-huh,
O2, which is
O2.
also a general formula for carboxylic acids and esters. And reminding that now esters and carboxylic acid are functional isomers. So I believe we should be,
Isomers.
yes, we should be in a position of accepting.
Yeah, because they are isomers. Yes, I think. Yeah, maybe Mebusi can also come up with a suggestion. But now that you have said that, because I could not figure it out immediately, but I think we can accept that, knowing that they are isomers.
Isomers, yes.
Yes.
So
Yeah, I
CN,
think there is a colleague who also sent that as a WhatsApp message. So I
okay.
said I would look into that. So if we agree, we can give that mark.
Uh,
Then
co-
that means I will have
yes.
to add there.
Then we can give colleagues for CN, H2N, O2, 4513. Ntatembele, your hand is up. Ntatembele, Mr. Mbele, the platform is yours.
Okay, thank you, Mr. I just wanted to ask about it because the learner got it from the terms and definitions on page 3.
Or the same question of the general formula.
Yes,
Okay,
yes.
now we are going to accept, sir. Thank you very much.
Yeah, no, I think it is addressed already.
Thank you. I don't see any. Okay, there's Mr. Mbele again. Mr. Mbele. Mr. Mbele. Okay, while Mr. Mbele is
It was a mistake.
oh, it's an
It
old
was a
hand.
mistake, sorry.
Okay, no problem.
Yes.
Mr. Elvis Mzaifani.
Okay, thank you so much, Nambani. Can we go back to 5.3?
5.3.
Yes,
Okay.
5.3.
5.3. I just want to ask, how many marks should I as a teacher allocate if a learner drew the structure very correct, but he made a mistake of not including one H on a certain carbon?
In
So
Tatechaka, let's look
the
into
functional group is correct.
the marking
Maybe that
criteria
is-
quickly.
Yeah.
Tatechaka,
Colleagues who are in paper 2.
yes, let me quickly answer Tatechaka. Tatechaka, let's check the marking guideline or the criteria that is given to
Yeah,
us. If the
yeah,
functional group is
yeah.
correct with the triple bond, you will award a mark. If there are 3
Yes.
methyl substituents, you'll also award a mark. But now for you to award this mark, that will give now the
The
learner
last
3
one.
out of 3. It says the whole structure should be correct. What does that say? It means all hydrogens should be there, all bonds should be there, the triple bond should also be there, as well as 3 methyl groups. So there isn't any mistake that the learner should have done. So any omission of a bond, hydrogen, will not allow the learner to get this mark of the whole structure being correct. So that learner will get 2 out of 3 instead of 3 out of 3. So if there's no H, there's no hydrogen, there's no bond. Remember, the last bullet will be a guideline as to how do we award a mark for that.
Okay, Mr. Nambani.
Thank you very much. Do you
Mr.
have
Nambani,
a follow-up question?
yes, actually, the learner drew the structure the way it appears, but on methyl, like carbon number 2, the methyl there, he wrote C, but he forgot to put the H's. So I just want to know, this one mark that is allocated for 3-methyl, am I allowed to allocate that mark to a learner or not?
you cannot award Miner because remember, for us to consider it as a methyl, it should have those 3 hydrogens. So definitely then bullet number 2 will not be attended to. So no mark for that.
Automatically, even bullet number 3, that learner must get 1. Ne?
That learner will only get 1 for the functional group.
Thank you, sir.
Thank you very much, Miner.
Thank you very much, Nadine, for coming in there.
Thank you, Ntate.
Because these rules in organic chemistry are
Motlou.
Ntate, good morning, Ntate.
Good morning, Ntate.
I'm seeking clarity in question 5.1.3 that we said we accept CnH2nO2.
Yes, sir.
Okay, thanks.
Thank you very much.
welcome.
Teboho Mbuliswani. Teboho. While we wait for Teboho, let me quickly give okay, Tate Teboho.
That number, I wanted to ask if the learner 5.2, 5.2.2, question 5.
5.2.
5.2.2.
5.2.2.
Yes.
Okay, Miner.
If the learner wrote 2.2 dimethyl 3 hexene instead of 2.2 dimethyl hex 3 in, do we allocate 3 marks for that? Or
okay, the first thing to consider, Miner, is if it's 2,2 dimethyl dash 3 dash hexene, then everything should be correct in terms of the positioning of the hyphens. The only way of us awarding a mark is if that 3, between the 3 and the hexene, they are hyphens, not commas. So it basically says all the hyphens should be correct for us to award a mark for that 3 hex 3 as well as the in. So we can award provided that the positioning of the hyphens is correct, Munir.
okay, thank you very much.
Thank you very much. Mekrai.
Thank you.
Mekrai. Okay, it looks like Mekrai has now disappeared. I think, Munir, we can kindly go to question 6. I do not have any questions from the colleagues. If there are any, I will address on the chat while you continue with your presentation.
Oh, thank you very much, Nadine.
Thank you.
I think question 6 is the last question on the paper. It says compound A, B, and C shown in the table are used to investigate a factor which influences the boiling point of organic compounds. So these 3 compounds are all aldehydes. Accordingly, but we can see that the chain lengths are increasing. So 6.1 says define the term boiling point, and for that we said the boiling point is the temperature at which the vapor pressure of the liquid equals the atmospheric air pressure. I think the word temperature there would be a key word, and that the vapor pressure equals the atmospheric pressure. So if one of these keywords is omitted, then you will take off 1 mark. 6.2 2, which one of the compounds A, B, or C has the highest boiling point? And then we need an explanation. Which one of this will have the highest boiling point? C will have the highest boiling point. And the reason is that it has the longest chain length. I think that relates also to say to the fact that the factor which influences the boiling point, I think Lena here identifies that as the chain length. For 6.3, it says, for this investigation, write down the independent variable. You know, these variables, the independent variable is the one that we are controlling or changing, and the dependent variable is the one that depends on the changes that we make on the independent. So 6.3.1 says, which one of this is the independent variable? And according to this, we said the chain length is the one that is independent. It is the one, if it changes, then the dependent variable will depend on that, will behave, respond in response to the independent variable. So the dependent variable will therefore be the boiling point. So we are looking at the influence that the chain length has on the boiling point. So the chain length will be the independent variable and the boiling point will be the dependent variable. 6.4 says, write down the names of the two types of van der Waals forces that occur between the molecules of compound A. Colleagues, I think there was also a mistake on this one. Fortunately, colleagues responded, and we looked at that because we said these are aldehydes. So the type of intermolecular forces, not bonds, the type of intermolecular forces existing between the molecules, they are not really polar molecules as you would have hydrogen bonds or any of those polar bonds. So we have London forces and dipole. You remember this dipole forces are just momentary poles that are produced due to the movement and the changing positions of the molecules. So yeah, the correct answer there should be London forces and dipole forces. And thank you, colleagues, for that correction, so that all of us can really, mark in the same way. 6.5 says, how will the vapor pressure of 2-methylpropanol compare to that of compound B? I wonder if I did mention this. Oh yes, 6.4, that's 6.5. This, colleagues, I think in the English version was correct, and that was how we were thinking of answering the question. But now I don't know if then there would be discussions around this, but take it back to your learners, emphasize those three key points that the compounds have the same functional group and the same molecular mass, but we do not award a mark for that. 2-methylpropanol has branching and hence a smaller surface area. 2-methylpropanol has weaker intermolecular forces. You can name, or the learner can name the type of intermolecular forces, but already we have said These are dipole forces. If I'm not mistaken, then less energy is required to overcome weaker intermolecular forces in that compound. So I think it's just a question of going back and stressing that with your learners and giving them more work. But for this particular marking, because of that challenge that we have, then this question will be left out. Question before we get to question 6.6, it says the boiling points of compound D and E shown in the table below are now compared. You have compound D and E, and compound D is a carboxylic acid, and compound E is an alcohol. So in 6.6, it says write down the name of the functional group of D and E. So the functional group, they say the name will be the carboxyl group for the carboxylic acid, and like in the other case, because already we talked about the functional group, so if Elena just writes carboxyl, you don't have to worry about the him or her writing a group in there, so we put it in brackets. 6.2.2 is the alcohols, so the functional group in alcohols is the hydroxyl group. Question 6.7 says the boiling point of compound D is higher than that of compound E. Explain fully there. We also thought we should make a change because both bullets 1 and bullet 2 refer to hydrogen bonding between the molecules. So we thought we should bring in the strength of intermolecular forces. So while we can indicate that both compounds have hydrogen bonds between the molecules, then we would not give that both of them have, but compound E has one side for hydrogen bonding while compound D has two sides. So in this case, we are comparing the sides for bonding, and then we would say therefore that compound D has stronger intermolecular forces because of having two sides for hydrogen bonding as compared to compound E. And then in terms of energy, more energy is needed to overcome intermolecular forces in compound D. So that is the change that we thought would give learners a better chance, especially because now we've introduced the idea of the strength of intermolecular forces. I don't know if there will be questions.
Adelatina, thank you very much. I don't see any questions in the chat. And Tatum Klong, is your hand still up? Me Petunia Chivazinji. Yo, ma'am, your line is very, very bad. Can you maybe kindly type your question?
What about now?
Very bad also, ma'am. Your line is very, very bad. May Petunia, kindly just type it in the chat because we cannot hear anything from your side. Colleagues, as a quick reminder, while we wait for Mechavazinji to type her question, I've sent now the link to the register. That is the only foolproof evidence that you indeed attended this session. So kindly fill it up. It was sent around 11:18. I will send it again now very quickly so that those that joined the meeting late can also access it. Uh, Thank you very much, Ntate Letina, for a good presentation of the memo. I believe all the challenges were addressed. If there are any, should be issues of, is the question paper still out of 100? I think you addressed that it is now out of 90, 96 for both Afrikaans and English. Correct me, Menere, if I'm wrong.
Yes, that is correct, ma'am.
For both English and Afrikaans, the total it's now 96. So let's be aware of that, colleagues. If you do not know, remember which questions were taken out, kindly revisit the memo. Like I did say, the memo will be available on the Nambani Academy YouTube channel as a recording, so you can just go back to it. Ntate Mtlou, let me start with you.
And that is,
Yes, sir.
my question is based on question 6.5.
6.5.
Yes.
6.5 Ntate. Yes, sir, you can continue.
Then what if Elena in his or her explanation um, talked about compound B instead of chemical propanol by adding by saying compound B is a straight chain while 2-methyl propanol is branched. Then compound B will have stronger intermolecular forces compared to 2-methyl propanol.
So instead of referring to both compound D and E, but specifying exactly which one is compound D and which one is compound E. That is
No,
what.
instead of answering based on 2-methyl propanol, but
Mm.
the learner may his or her answer based on compound B.
Oh.
It's a straight chain, then it has larger surface area. Then compound B has a strong intermolecular forces,
Mm.
then more energy are required to overcome the intermolecular forces of compound B.
Okay. So basically,
Then
what you are referring to is a learner who now said, instead of 2-methyl propanol, referred now to the one with now larger surface area, weaker
yes,
intermolecular forces, and so forth. Ntate Letina, it's just now the opposite of what we have here.
yes,
6.5.
The learner talks about, I
They have
think,
the same functional group and same molecular mass, and then hence branching and hence smaller surface area. But now the other one
we
says,
are saying 6.5.
yes, 6.5.
Okay.
Yes.
So he's talking about,
Instead of comparing to 2-methyl propanol, the learner refers now to propanol.
oh, yeah, okay. If that is the opposite, because if the learner then refers to propanol, then I think it's the other alternative. If I have not missed the question, it will be the other alternative that you, or the other option that you would give. Unfortunately, we did not give here that option. But I think it's something that we need to note, that if the learner did not talk of 2-methyl propanol, but rather compound, is that compound B, then it should be the other way around.
Where I am, Tati Letinane, I will say that learner will
Yeah.
only get 1 mark for higher. The reason being, if you check the question again at 6.5, it says, how will the vapor pressure of 2-methyl
Or,
propanol? So the
or
reference
compare with
point,
that also.
yes.
Yeah,
So
yeah,
the
you're right.
reference here is 2-methyl propanol. The choice of the answer, which is higher than, refers to the
It's
explanations
to,
of 2-methyl
yeah,
propanol.
yeah.
So
No,
it's
no, I
it's
agree with you that
yes, so it's not opening up a discussion of
to say
what will
compound,
happen
yeah,
now to propanol
yeah,
only. The idea
yeah,
here was learners understanding now in terms of branching of 2-methyl propanol
yeah,
as well as
propanol,
propanol. So it means that learner will not get 4 marks, will only get 1 mark
for the higher,
because yes, 1 mark for higher than and then no mark further because the
for the
indication here
explanation,
is
because now he
clear.
uses the other compound.
He
No,
is
thank you
using
very
the
much,
other
Nadine.
he's using the other compound, so we cannot give
Yes.
for that.
No.
Thank
And thank you very much for that, Nadine. And then I think then the teacher should go back and show the learner why then
no mark was given.
answer is not, because yeah, no, I understand that, yes.
Okay. Ntate
And I think it's also the same for all of us, that we should just show this learners also that, here the question specifically says compare this compound
to
to
that
that one.
one.
So you reference of this
Yes.
compound. You will let the vapor pressure or boiling point be higher for this one or lower. And then, yeah, no, thank you for that, Nathan.
Thank you. Ntate Mbele
But the register you sent at 926 is the same or is it different from the one that you send now?
is the same, sir. Just repeating for those that
Okay,
came late in the meeting.
okay,
Thank you very much.
okay.
Tlokolwa SS. Tlokolwa SS. Okay. I think the question of Match Havazinji is here. Question 6.5. If a learner focuses on compound B, not 2-methyl propanol, I think we have addressed that. That learner will only get 1 mark for higher than, and the rest of the marks will be forfeited for that. I believe so. Colleagues, Tlokola, your hand is still up. The platform is yours, and then I will be in a position of closing this particular meeting. Tlokola SS. Okay. Colleagues, with that being said, thank you very much for attending this memo discussion. And I believe it's an eye opener to our learners and to us as teachers, so that when we go back and address the issues of this particular paper, we are actually preparing them now for what the final examinations will be like. We are preparing them for June examination also, so that will assist us in terms of ensuring that as Free State we maintain the position that we are in, and we have registered a great improvement in terms of our NSC results, specifically looking at physical sciences. So colleagues, with that being said, just a kind reminder, those that are watching on YouTube, I did also send the register link also on the YouTube chat, so kindly fill it in. And if it happens that you know a colleague that is going to watch also uh, this particular recording on YouTube, just notify them that on the comment section there will be a link to the register. So the link will be open until Sunday 12 o'clock, and then we will close it off. And colleagues, I must remind you that we'll also send out links later today for curriculum coverage until week 8 with proper instructions. Colleagues, with that being said, thank you very much from my side and Dadele Tena, and all the best and happy marking, and be ready to complete those error analysis so that you can be able now to see how best can we assist our learners. So colleagues, from me to you, thank you very much and have a lovely day.
Thank you, Nadine, and thank you, colleagues.